Hello folks, welcome to a new video. In this video, we'll be exploring Redis persistence. Now, as you know that Redis is an in-memory database, but it also provides you persistence. That means you can dump all the data in your database and you can just use that file for a recovery or for your, let's say, archival. So it has two ways to take backup. The first one is RDB, that is Redis database backup. What a non-creative, very uncreative name for a protocol. The other one is Redis AOF, that is append only file. So let me just finish with AOF very fast. Okay, so AOF is nothing but it is just putting every time you are changing anything in Redis. Let's say you are setting some key X to A, or you are setting some sorted set value, or you're increasing score of a sorted set value. Okay, so every time you're mutating state of the data, it is just recording that operation and it is putting into a log file. Okay, now the benefit of this thing is you will get everything in that file. Every time you're changing the data, you are writing this to this file. That means you will get the latest database dump using this mechanism. But that is the drawback also, because every time you are making any change in the database, it has to be written and has to be synced to the disk using the fsync system call. That takes a significant amount of time. That means this will slow down your entire database. Okay, so it is very reliable, but it's also makes you slow. The second thing is Redis database backup, which is RDB, which provides you point-in-time recovery. Now, what is point-in-time recovery? Point-in-time recovery means it will just take a snapshot of memory at the time it starts backing up. Okay, that means, for example, if the next, let's say, if the next backup is scheduled at 6 p.m., that means whatever was there in the 6 p.m. At the moment of 6 p.m., it will just take that memory and it will dump that memory into a file called RDB files. For RDB database, for RDB backup, Redis uses one binary format, not like REST. In REST, which is the communication protocol for Redis, it uses text-based protocol. But since the size of the data is huge, it is now supposed to use binary format. Okay. Now, what is the drawback of this thing is, for example, you have intervals of 15 minutes for your backup. That means once you take backup at 6 p.m., you will again take backup at 6:15. Okay, let's say the backup was taken at 6 p.m. If your database crashes at 6:12, you will lose all the data for those 12 minutes. Okay, so this is a drawback, but it is also very fast because it just need to take the snapshot and put it to a file. So it is not doing fsync, or it is not writing to the disk every time you are making any change like AOF. Okay, so the implementation of AOF is very simple. That every time some command is coming, you just need to log into a file. The interesting part is how RDB is implemented. Okay, so think from a system engineer, software engineer perspective. How will you design something, some similar backup mechanism for a in-memory database which runs in a single thread? Now, one thing that comes to our mind is that it is a single-threaded database. So what I can do is I can take the backup in the main thread itself. Okay, that means whenever I come to the interval, that means, for example, if the backup is scheduled for 6 p.m., I will just stop in the thread itself. I will just stop all the other operations and just whatever I was doing, and I will just take this data dump and I will write this data into the file. Now the drawback is, okay, for example, if you are taking backup of a, let's say, 4 GB memory, okay, that means you have to convert this 4 GB of data into a binary format, and then you have to write it into the disk also. And if it takes, let's say, 800 milliseconds, your database will be blocked for that amount of time. And now you might think that 800 milliseconds is nothing, but if we talk about large scale organization or organization who have more, like, very high scale, it's a huge thing. Like 800 milliseconds of blockage is a huge thing. Okay. Another dumb idea that you can think is that why not we just start another thread? Okay. Many other database does implement this strategy, but Redis is an in-memory database. That means every time you need to you will start this thread, but this thread has to have exclusive right to your data your data set also. It can't happen that this thread is just taking the backup while this thread it mutating the data. It will have race conditions. Okay, so we can't spin another thread also, because you have to take that lock on the entire data structure. That means your database will be blocked. So it is similar to doing the backup in main thread. Okay, you're not saving much. Okay, so how does Redis implement this thing? So Redis takes neither of these approach, that is doing this in main thread or spinning a new thread. It will just copy the process. Okay, now what is copying the process means? That it will fork a new child process which will be similar to the main process. Okay, it does this using fork system call. It is very popular system call. If you are from engineering background or computer science background, you would be familiar with this system call. Okay, so how does this process forking actually copies the memory? It is not supposed to copy the entire data which was presented in the parent process to the child process. That means if you had 4 gigabytes of data in the parent process, it will just clone the entire 4 GBs and the total memory consumption would be 8 GB. It is not going to happen. Okay, so what it does is it just copy the page table of the process to the child process. Now, what is this page table? So whenever we are manipulating memory, we think that memory is just a linear array. Okay, like we have infinite amount of memory, and it is a serial array. Okay, so memory block is aligned one by one. Okay, but it is not like that, because see, when you're running your program into any system, that program is not the only program which is running. We have thousands of programs running, and every program is allocating and deallocating memory, and everybody is thinking that they have a linear array of data. Okay, which is impossible. Okay, you can't have something like that. So how does operating system solve this problem? Is using a page table. So page table is just a table which is in the kernel memory, which has mainly 3 things. Okay, not mainly, it has mainly 2 things. The first thing is virtual address. Virtual address is the memory address that you will get into your program. Okay, that you will think that this is the address of my memory, which it is not. Okay, now this virtual address is actually linked to a physical address in the RAM. Physical address will tell you at what location in the random access memory your data lies. But you will think that your data is situated at whatever address the virtual address is pointing to. Okay, now this virtual address provides you a sort of abstraction. Okay, in the diagram also you can see that we have at address 1 we have this data called hello. Okay, and at the address 2 we have a data called something. Now this address 1 and 2 are continuous. Okay, so you will think that your data is just side by side in the memory, but actually the data is located very far. Okay, in the physical memory, the memory address difference is huge. Okay, so page tables give you an illusion that you have this linear data with you. Okay, and it is nothing but just a memory mapping. So what we are doing is we are just taking copy of this page table, and we are just copying this data structure which is page table to the child copy. Okay, since the actual data lies into the physical address, if I copy this table at whatever address my variables had, which was the virtual address, they can still access this memory. Okay, but it is okay. Now you might think that okay, this is a very good optimization. Okay, we are just copying the page table. That means we are not doing any kind of actual data copy. We are just mapping. We are just copying this table. So whenever I want to access one thing, I can easily just get the data wherever it is located. Okay, good optimization. What happens is that when you have forked one process, now you have 2 copies of the single program. Okay, what happens when one of the programs does some kind of update on this thing? Okay, now we have a problem, because now the copy of data is separate for process 1 and process 2. Now let me just show you another diagram. So this is the representation of the page table of the parent. Let's say Redis parent process. Okay. It is similar to the previous diagram I showed you. Now we are forking one process, so the table will be copied into the child process. Okay, which is similar to the parent process after forking. Now if the parent process, that means the process which is actually listening clients and actually serving clients, if it modifies something, let's say while you are taking a database, somebody asks you to that please set this value to this value. Okay, now what will happen is the operating system will do the will copy the page. Okay, whatever page you were there. For example, you want to at address 1 we had this thing called hello. Okay, at the virtual address 1 we had this thing called hello. Now we are going to we want to update this thing to hello world. So what will happen is the virtual address will remain same for the parent process, but the physical address will be changed, because operating system will copy whatever was there in this page called 0x100. It will just copy whatever content it had to another address which is 0x870, and it will append the world part. Okay, now but since this new page is also linked with 0x1 address, the program will not know anything about this thing. Now but you can think that the modification has happened in the parent process page table and not the child process page table. So the data will remain same for the child process. So this is how we are just copying. We are just sort of doing a shallow copy, you can say. You can just you are just copying the page table, and whenever one update comes, we are just uh, updating only that part of the page table so that the data remains same across two child processes. Sorry, across two processes. So this scenario, this thing is called copy on write. So this is how Redis implements its backup strategy using page tables, using copy on write. Copy on write is a very popular mechanism. You might find other use cases also, but this was the one that I was very fascinated about when I got to know. Now, to show you more how these things work, I've prepared one small program also, which you can find on my GitHub, which is linked in the description box. I'll give you a small demo of that program. Okay. So this program is written in a programming language called Zig. Zig is a C alternative. I tried implementing this program in Golang also, but Golang is not very open about creating this child process because of its runtime. It runtimes manage everything, so it is not very compatible or comfortable with forking a new process and all. At least this was my experience, and I wanted to explore Zig also. Okay, so I have built this program for you. We will call this cow, which is copy on write. Let me just show you the all the options that we have with us. Okay, so currently we have 3 options in this thing. I will show you 2 variants of it when we are using threads to take a backup and when we are using a forked process to take a backup. Okay, you can play with the cache size. Cache size would be in MB. This demo will be for 512 MB, that is half of GB. You can play around. You can make it 4 GB or 8 GB, but don't crash your computer's memory. The other part is interval, at which interval you want to take this database. Okay. Okay, cool. So first we will do with a child process. Cool. So it does not have any actual data. What it will do is whatever cache size we are giving, it will just allocate that much amount of money. Sorry, not money, memory, and it will just try to make changes to it. Okay. So let's before doing the process example, I'll give you the thread example so that you can have a better contrast of their performances. Okay, let me just rebuild this entire program. You need to install Zig if you want to use it on your system. Good, done. Now let's make the cache size 1025, that is 1025 megabytes, and the interval would be 20 minutes. Let me show you this process is being so this process is working, and currently it won't show you anything because it has to wait for 20 seconds to take the first backup of the data. Okay, you can see the memory usage is 1025 megabytes. 1 megabytes is taken by the program itself, I'm assuming, and 102524 is the amount of memory that I asked for. Okay. So now this thing is started. You can see that before doing this thing, just to give you a demo, I'm just taking the hash of the entire data set. So this was the hash of the data set before taking the backup. Redis does not do this thing. It is just for the demo purpose, so that you understand that this forked process is not doing any kind of updation, or it does not affect it once the main process to modify the data. It will just had the same copy across the backup process. Okay, so this is we are in the parent process. Okay, we just started the child. Parent has created one child which has the ID 4148. Now child is about to start the backup, and the backup took 441 milliseconds. So as I told you, and I'm running this on my MacBook M2 Pro, which is a very good computer. Okay, with respect to memory also, with respect to disk also, with respect to CPU also. So dumping 512 megabytes of data took 440 milliseconds. So you can assume that what will happen for 8 gigabytes of RAM. Okay. Now after taking the database, after taking the backup, I'm just again showing a hash that this was the data that was backed up. Okay. So this hash and this hash is same. That means while we were doing the backup thing, it hadn't changed. You can see that at this point we spend the new child. Sorry. Yeah. At this point we were supposed to spend the new child, and at this point we spawned it. Okay. That means it was running in background. Okay. And it was taking the backup also. That means it is happening concurrently. We had two processes that were running simultaneously. Okay. After taking the backup, the child is leaving. Okay. Once the child leaves, the parent has to consume the signal it is giving. So whenever a child process ends, it has to send a signal to parent that I'm going, okay, have fun, okay. Once the parent receives the signal, it has to then read the exit code, what was the exit code of that process. Now these are the nitty-gritty details. You can just read your operating system books for these kind of, if you want to get into more depth. But this is how this process thing is implemented. Now you can see that we are doing this backup thing in every I think 20 seconds. Yeah, 20 seconds. Okay, and it is being repeated every time. This time it took 939 millisecond, which is around 400 milliseconds. Okay, we'll be moving to the next example, which is the similar thing but with threads. Okay, so I will just add this new argument, which is use thread with 512 megabytes. Okay, and let's keep it 15 seconds. You can see that the process is running. This is the main process. Now in this example, we won't spin a new process. We will be spinning one new thread. Okay, so cool. So this was the main thread. It is about to spin the thread. Then it spawn a backup thread. Backup thread has to acquire a mutex, because I told you that we have to take a mutex before modifying or before reading the data. Okay, before modifying the data, it took the mutex. Okay, now since we are doing this backup in some secondary thread, the main thread will go and it will try to take the lock, but it won't be able to take the lock because the lock is already taken by this other process which is taking backup. So okay, so this was the video about how RDB is implemented in Redis. You can check out the code base. It is mentioned into the description below, and the code is probably commented. If you want to know anything or any part of the code, you can just comment below and I'll try to figure out your query. So thanks for watching this video.